today you guys are going to be doing 3.5 traits. Your learning target for today is I can explain why siblings look different. So we all have siblings. Possibly you guys have the same parents as those siblings, if they're full siblings, but you do not look identical to them. Even identical twins don't always look identical. Anyway, moving on, if you guys aren't sure if you are green group or not, you guys will use this link right here to open it and see which group you're in. So when you open this, it will tell you your color group. It's going to log me in. It's going to probably take its sweet time. So I'm going to go ahead and say if you guys find out you are green group and you're obviously watching this video, you need to know that you are only completing slides 9 through 15 today, as well as 21. 21 is your little wrap-up self-assessment slides. So when you guys open that first link up, you guys should see your color group right here. In this case, you could see either blue group, green group, which you guys are, or purple group. Okay, so if you popped up as green group, you are green group today and you are in the right video. Okay, so again, you are completing slides 9 through 15. Okay, so let's go ahead and skip the first 3 through 8 and go right to slide 9. Okay, so what you guys have on slide 9, your guys' important color today is pink. So anytime you guys see this pink question mark or the pink text, that's where you guys have something to answer. So you need to look at this diagram, read through it. Remember, you guys can always zoom in on things to see them a little bit better. And you guys are going to add a caption for this diagram. So I'm going to blow it up just a little bit for you guys. And then you guys can write that caption that explains just a little bit about your diagram. It might be a summarization. It might be trying to explain to someone what it means. It might be kind of what you guys learned from it or what you took from it, but I just want a couple sentences there explaining this diagram. So what you guys see is reproductive cells from your mother. So it looks like they have 2 eggs right there. And reproductive cells from your father. So in each of those, we have chromosomes. And I want you guys to think about this. Are those chromosomes the exact same? Okay, those little colored bands indicate genes. Okay, so think about what different color bands right there might mean about the genes. Okay, and then all these little arrows show all the possible combinations if one of these eggs were to be fertilized by one of these sperms. So it kind of shows you guys a combination of, this egg could either go into these 2 combinations, so this egg and this sperm, or this egg and this sperm. Okay, so it shows you guys all the different combinations that you guys could form between these 2 eggs and these 2 sperm that a mother and a father might produce. Okay, so cells of different possible offspring, each with a different combination of genes. Okay, so these could be 4 siblings right here. Okay. All right, moving on, answer this question using that same diagram. So use the diagrams from the last page to answer the question. How does this diagram help you understand why siblings can have different combinations of gene versions? So how did that diagram explain this question for you? All right, moving on to part 2 is the simulation. So if you have not already, there is a link for you guys to right-click and open here. So right-click it, open, and you guys should be launched into the simulation. I'm going to go ahead and reset mine just to be sure. All right, so for your guys' examples today, you guys are going to be predicting offspring. So you guys are going to be taking a look at 2 parents, looking at what their genotypes are, and then making predictions of what could they pass down in their sperm and egg. And if we were to fertilize those eggs with those sperm, what different combinations could we come up with for genotypes for the offspring? Okay, so you're going to launch the sim, and you're going to look at Otis and Zora. Okay, so you guys are going to be looking at the trait of venom, and you guys will record Otis and Zora's traits and gene versions for this feature. So let's go ahead and flip to the next slide. Obviously, there's nothing for us to answer here. There's no pink question mark, but the next slide has things for us to fill out. Okay, so what you're going to do is go ahead and select Otis first. Where is he at? Here he is. And we're going to look at venom. Okay, so here is Otis's genotype. He is V1, V2. So you guys would answer that right there in genotype. And what is his phenotype? So that's his physical appearance. You guys have a couple options for venom. He can either kill, stun, or no effect whatsoever. Okay, so in this case, Otis is a poisonous spider, so he kills. That is his phenotype. You're going to do the same thing for Zora. Exit out of Otis, go into Zora. She has V3, and she has no venom at all, so she's pretty harmless. Okay, she's a nice spider. Okay, so record her genotype and phenotype. And what you guys are going to do is you're going to list all the possible combination of gene versions and traits for Otis and Zora's offspring. So let's take a look at this. I'm going to draw on this for you guys. If you have, let's take a look at Otis since we already kind of talked about him. Otis has the genotype V1, V2. So what are there's only two possibilities. What are two possibilities of what allele Otis could pass down? Okay, so Otis can either pass down V1 or he could pass down V2. Okay, so he's the male in this mate, so he would be producing sperm. So his sperm are either going to be V1 or V2. Okay, Zora, on the other hand, is V3, V3. So she, even though she has two copies of this gene, she has the same copy, so she really can only pass down V3. So if we were to look at Zora's eggs, all of them would be V3. Okay, so then what you're going to do for this is possible genotype combinations. So you'll need to click back on, or excuse me, I need to click back on cursor. So what you guys will do in here is you guys will click in these boxes and you guys will predict how many different combinations of genotypes that you'll see for offspring. Okay, so if Zora passes down V3, okay, and Otis can either pass down V1 or V2, what are the possible offspring options that you could have? So an example might be, all right, Dad's going to pass down V1. And again, Mom only can pass down V3. So you would look at that and say V1, V3 is a killer, okay? So their baby could kill, okay? What other options are there? So we could pass down V2 and V3, and that baby would stun, okay? So because Zora can only pass down one option, you guys are only going to be filling out two boxes in this table. Okay, let me go ahead and just delete this stuff. All right, and then finally, you guys are actually going to test that theory. So you're going to go and grab Otis and Zora and mate them. So you'll click one and drag. It doesn't matter how you guys do it. And you guys are going to create reproductive cells. So as predicted, we said that because Otis is V1, V2, he could only pass down V1 or V2 in his sperm. So you guys can see that that's exactly what happens is we only have, there's 6 possible options. 3 of them are V2 and 3 of them are V1. So one of those is going to get, or some of those randomly are going to get selected versus Zora's V3, V3, so all she could pass down is V3. All right, so then you guys will go randomly fertilize and we'll randomly mix our sperm and our egg to cause fertilization. And if predicted, you guys will only have V1, V3 and V2, V3. So if we look, we have V2, V3, V1, V3, V2, V3, V1, V3. So we were right in our predictions. So you guys would go ahead and record those 4 offspring's genotypes and their phenotypes in this table right here. Okay, moving on, you have some questions to answer about this simulation activity. Question 1 says, explain why there is variation in the traits of Otis and Zora's offspring for the venom feature. So you guys are explaining that. Why are there multiple different traits in Otis and Zora's offspring? So how can they have stun? Neither of them were stuns. Okay, Otis was a killer and Zora was no venom. So how can they have different variation where they see offspring that have stunning? Okay, try to use the following words in your explanation. Gene, heterozygous, remember that means a mix of alleles. So both of those parents, Otis was heterozygous. He had V1, V3 versus homozygous. Zora was homozygous. She was V3, V3. You can use protein. That's a big one that I definitely want you guys to use. Sexual reproduction, trait, and variation. Okay. People with a genetic disease such as hemophilia. We learned about hemophilia a couple lessons ago. Remember, it's the condition where you genetically can't clot your own blood. You don't have the genes that make the proteins that clot your blood. Cystic fibrosis, though, is a disease where you guys make a certain protein in your lungs. And when you have that mutation for cystic fibrosis, You don't make the protein correctly, and what it does is basically causes a buildup of fluid in your lungs. Can be deadly if not treated. So people with genetic diseases such as hemophilia or cystic fibrosis also often want to know how likely it is for their children to have the same disease. Based on what you observed in the sim, if one family member has a disease, will all the family members have that same disease? Why or why not? Okay. Finally, you guys are moving on to your last activity. It's reading. So go ahead and read this little article. You'll find a little bit more about cystic fibrosis, which I just explained to you. And then you guys can move on and answer these questions. For these questions 1 and 2, you guys will need to use the draw tool. So just circle which answer correctly answers question 1. George has 1 copy of this cystic fibrosis gene that instructs for a non-functional protein, meaning it doesn't work correctly, and 1 normal copy, so it's a healthy copy of the gene. Sylvia has 2 normal copies of the cystic fibrosis gene. Which of the following could be true of their children? So their children could have 2 normal copies. Their children could have 1 normal copy of the CF gene and 1 copy that instructs for a non-functional protein. Or their children could have 2 copies of the CF gene. So circle the correct answers. Okay, and then could any of their children have cystic fibrosis? Circle yes or no. So is it a possibility? And then explain why you answered either yes or no above. Use what you learned about genes and inheritance to support your answer. So you guys should be able to get a lot of help from this little reading on cystic fibrosis. Okay, finally, skip down to slide 21. This is your self-assessment. So tell me how you think you did. Okay, any questions, yes or no? If you guys have a question, type it below. Obviously, if it's preventing you from completing this assignment, send me that question right away in Teams so I can help you out and get you moving forward. And then finally, circle 4, 3, 2, 1. Tell me how you think you did. You need to do this slide. It does not take long at all, but I want you guys to really think about how you're doing on these assignments. Okay, I hope you all are having a great day. Once you're done, go ahead and turn it